Hi guys, welcome to the third and final part of showing you fundamentals versus advanced for our new HSC preparation course. So the first question here is from our fundamental stream. As you can see, both of these questions are kind of testing the same concept, but just in a different way. So if we look at our first question, let's start off from the very right. Now we're asked to find X, but generally you should start with a compound that you already know the identity of. So this is following oxidation, and generally you can only produce either an acid or a ketone, depending on the nature of your alcohol. Now this has 2 oxygens in its formula, so that's likely to be an acid. So if that's an acid, that means that our alcohol here has to be primary. So looking at the reaction that precedes that, that's hydration. So this has to be an alkene of some sort, meaning I can cross out A and D from our options, which both aren't alkenes. Now, if I just draw out the carbon backbone for you for both but1-ene and but2-ene, let's have a look at which one can actually produce the primary alcohol. So opening up the double bond for but1-ene, we can either have the OH on the first carbon, or we can have the OH on the second carbon. So either a primary or a secondary alcohol. But for but2-ene, what you'll notice is no matter how hard I try to put it on the first carbon, you just can't. It's either the second, or reading from the other way, also the second. So both are going to be our secondary alcohols. So this means that our answer here is but1-ene, because it's the only one that can produce the primary alcohol. So moving on to our advanced stream, you can see now it's a bit more difficult because we have all of these reactions to consider. So let's again start off from what we know. This one here, if you remember your homologous series and their formulas, this is an alkyne. The reaction that uses this alkyne going up is hydrogenation, poisoned by lead. So this will stop at an alkene, not an alkane. Moving to the right, that's hydration. So this will produce an alcohol, and then moving down, that's oxidation. So this will produce either, remember, an acid or a ketone. However, this product is also formed from this mysterious reaction from an alkyne. Can't really produce an acid from that, so that tells us it's probably a ketone. So if we produced a ketone from oxidation, that means we had a secondary alcohol as compound B, and now we can start to fill things in. So if we look at this reaction here, what you'll notice is our 2 possible alkynes are going to be this one here and this one here. However, if I try to add HBr onto it, what you'll notice is that for the first one, it will only give me one product. So if I try to put the bromine on the other carbon as well, these are both the same thing, just flipped around each other. Whereas for the second alkyne, what you'll notice is that I can produce 2, either on the first carbon or the second carbon. So there's no way I'm only going to get one product from that, which means it can't be the second option and must be the first. So our compound D is going to look like this, obviously with all of our hydrogens attached. Compound E from that, it's going to be a 1-to-1 ratio. So we're only subbing on 1 bromine, is going to look like this, again with all my hydrogens attached. Then our alkene is produced from hydrogenation from our alkyne. So that's going to give us this one here, again with all those hydrogens. Our secondary alcohol produced from that will have the OH on the second carbon, again with all my hydrogens. And then the ketone produced from that is going to be on the second carbon as well. Okay. So then the final part says specify the reaction conditions of F, which is the hydration of a alkyne. So that's going to give us, we need water for the hydration, and also HgSO4, H2SO4, and a bit of heat. So hopefully that sort of helps you decide whether you want to do the fundamentals or the advanced, and I'll see you next time.